very good evening to all of you, and my name is Rahul Kanyal. I'm going to take you through another session of industrial engineering, and we are going to start queuing theory today. All right, a very good evening, Mohammed Kisnaram. Good to see you again here. Okay, you have been a very consistent player, and believe me, that consistency is the key to any success anywhere. All right, so how are you doing, guys? How are you? Okay, till then actually what we have covered is, okay, you can post your comments out there, okay. So till then what we have covered is, last time we were doing production planning control, all right. And today actually we will be doing queuing, and I'll also give you a context of why do we need queuing, right. A very good evening, Garapalli. Okay, so Muhammad says energetic. Yeah, that's what you need to feel, Muhammad. All right, energetic. Okay, so how many of you have been in a situation of queue? Do you understand queue? What is the meaning of queue? So let's start with basics. What is a queue? Q-U-E-U-E. What is that? Yes, being in India, we all know what an experience of being in a queue is, right? Isn't it? So can you just quote in some examples out there of a queue? I hope this word is very clear to you, right? Queue. Yes. So what is the understanding? What is your understanding? I just want to understand that. Okay, Nirmal, yes. A very hello to you, Nirmal Kumar. Okay. Yeah, exactly. So queue means you just have to wait in line, right? For example, railway counter. For example, in banks, especially government banks, right? You have to stand in line to get a service, right? That is queue. Yes. Now we just study queue because, let's say you went on to buy a ticket or just a movie ticket, and let's say there are 100 people in front of you. There's a movie ticket that you want to purchase, and there are 100 people out there. So are you going to buy that ticket or not? Will you buy that ticket or not? Because 100 people are already standing in front of you. Yes or a no? And yes, ATM can also be an example. Kisnaram, all right? Yeah, so what do you think about it? Will you buy that ticket? Yes, I or an I? Just give me an option there, all right? Yeah. Mohammed says, no, he is not going to buy ticket because already 100 people are standing in front of him. Okay, there's nothing like a correct answer to this, guys. Okay, just tell me if you are going to buy a ticket like this. 100 people standing in front of you. Yes. So yeah, so obviously, even if I go to this cinema hall, I'm not going to buy this, frankly, obviously, because 100 people are standing, all right, in front of me. So too much of waiting time, right? So a company always fears loss of customers. Okay, a company or a firm actually doesn't want its potential customers to go away to competitors. That's why this queuing theory is, studied. And we are going to just study a very basic level of queuing theory. Yes, so that's what it is. Okay, then yes. So there's nothing like, the correct answer for this or the wrong answer for this, guys, okay? So just for that sake, okay, so we know that there's a queue, and what's a queue? Queue is nothing but, you have to wait in a line, right? For example, let's say this is a counter and these are the customers, and this is nothing but counter, okay? And this whole box thing is called system, all right? And this is called queue, Q-U-E-U-E, all right? And these are the people who 4, 5, 6 and lots many people. This is called input population. They are still not in the system. Let's say system can be a railway station. A system can be a railway station, guys, okay? let's say. So these are the people who are going to come in into the railway station. Okay? Yes, fine. So this is just a counter. These two are in queue, and this guy is getting the service. Alright? Yes, if train is after 1-2 hours, then I wait in queue. Okay, that's your call, Kisnaram. Okay, so for a company, they make sure that no one goes away just because of queue. Right? So that's why we are studying this, and I like to give a context of it. Okay, guys, I don't like to just go into questions. We will be doing questions, all right, but you should know the context of why we are studying something that we are studying. Right? So let's get started from now. Okay, this is nothing but input population. This is queue. This is system. This is a counter, assuming that there's just one counter, as it happens mostly, right? Bad luck to us. Okay. Yeah, so this is how it is, okay? Is that good? Yes? Okay, fine. Then, okay, and the model that we are going to study is this one, MM1, okay, infinite FIFO. So what is the meaning of this model? This M tells us that arrival, this one M, okay, arrival pattern is having Poisson's distribution. All right, and this one tells that service time is having exponential distribution. All right, is that good? Is that good? Have you heard of distribution? This thing, distribution. When I say distribution, what do you understand by that? Distribution. Now, even before that, let me ask you, queuing. In queuing, are we deterministic or probabilistic? Are we, okay, here, okay, let me go back, okay. So can you please tell me what is deterministic? I think we have had a discussion about this, deterministic, okay, versus probabilistic, right? What is deterministic? When we were doing CPM, I think, yes, we have had a talk about this, right? Hello, everyone. You there? Don't sleep. Okay, probabilistic. So what is deterministic and what is probabilistic? Let's firstly talk about that, okay? Yeah. So what do you think about this? Yeah, so what is deterministic and what is probabilistic? Deterministic means, just type in your answers, guys, okay? Quickly type in your answers. What is the meaning of deterministic? What does it mean and what does it mean? Yes? 100% confirm event is deterministic. Yes, you're sure about something, that's called deterministic. Probabilistic means you're not sure, right? You're talking in terms of probabilities, chances, right? There's a chance that I might qualify GATE, right? There's a chance that it might rain today. All right, so what do you think is queuing? Is it deterministic or probabilistic? Just type in your answers. Okay, Mohammed has written the answer, all right, and Kisnaram has also written the answer, and yes, I think they are, I'm not going to tell if they are right or wrong. So tell me, is queuing deterministic or probabilistic here? Yes, exactly. Sunil Kumar, a very good evening. Welcome you here. I hope your CIL's paper would have been good, okay? Even if it was not good, just keep on trying, guys, okay? Without trying, you cannot expect to succeed. So yes, queuing has to be probabilistic, right? Because we don't know how many customers are we going to face, right? We don't know how many people are going to come in a railway station, right? We don't know how many people are going to visit our let's say shop. So it has to be probabilistic. So that's why whenever we talk about probability, we talk about a probability distribution, all right? So this distribution actually you will read in mathematics, okay? Engineering mathematics. Is that good? Yes. Now, so is having exponential distribution. This is the assumption here. 1 means that just one counter. Here, this 1 means that there's just one counter, and the infinite here, this number way. Okay, I'm taking all these letters from here. M1. I've just written what is the meaning of each of these numbers or letters. Is that good? 1 is nothing but just one counter. Infinite means that infinite customers are allowed in the system. System can take infinite customers. And what is the meaning of FIFO? First in, first out. So what is the meaning of first in, first out? First in, okay, first out. So what is the meaning of this? First in, first out. Can you please type in there what is the meaning of this? First in, first out. That's what these letters or numbers mean, guys, okay? So, can you please think about this? Okay. Yeah, exactly. So, whosoever comes in first, he is going to be served. In case of a railway ticket or a railway counter, obviously, if the last person comes and he is served, then people are going to kill him, right? Just on a lighter note, not on a literal note, guys, okay? They're going to beat him at least, right? This hand broken or left hand broken or maybe had injuries and all. Yes, exactly. So we don't want that. That's why it has to be FIFO. FIFO is the most practical of queuing discipline, all right? This is called nothing but queuing discipline. Is it good? Yes? Hello? Okay, fine. So here, this is the model that we are going to read. Let lambda equals to arrival rate. Okay, and it's given in terms of customers per unit time, all right? Mu is service rate. Okay, the unit is same for a customer, for arrival rate, all right? Rate is nothing but the speed, right? We're talking about speed here. So with the speed with customers arrive, that is nothing but lambda, and mu is nothing but service rate. All right, guys? Hello? Is that it? Yes? Now, this lambda upon mu equals to system utilization. Okay, this is also nothing but probability that system is busy. Okay, and it has lots of formulas, guys, okay? Yeah, so that is also called traffic intensity. Yes, Mohammed, okay? That you're also right. This lambda upon mu is also called traffic intensity or just intensity. All right. Is it good? Just type in I or an I. Okay, today mostly we are going to do theory, because without theory we won't be able to solve questions. Okay, just keep on telling, guys, okay? Keep on interacting, all right? Otherwise it becomes difficult for me to move ahead, right? Because I don't know if you know or not, right? Yeah, so what do you think it is? Okay, fine. So even, we are very much lazy in saying I or an I. Just say anything. Okay? So this is called lambda upon mu is called probability that system is busy. Okay? Now 1 minus lambda upon mu this is denoted by rho, and 1 minus lambda upon mu is P0. That is nothing but probability that system is idle. Probability that system is idle, all right? Okay? Yes. All right. Now these things are given to you. You will take up problems and you will see that very easy problems come up, all right? Very easy formula based problems come up. Okay, so we'll look into it. Is that it? Yes, probability that system is idle. Now Pn equals to probability of n customers in the system equals to rho to the power n into P0, where rho is lambda upon mu and P0 is 1 minus lambda upon mu. All right. Is it good? Hello? Yeah, so this is what it is and you need to remember all of this, okay? Is that good? Now I'm going to write few formulas over here, then we are going to do some questions, all right? Now, length of Q. Length of Q means average number of customers in Q equals to lambda square upon mu into mu minus lambda. Okay, length of system, average number of customers in the system is nothing but lambda upon mu minus lambda. Is it good? Hello, you there? Everyone, are you there? Yes, just type in I if you're there. You just need to cram all of these formulas, okay? You just need to remember all of these formulas. Yeah, good Sunil Kumar, you also have been a very consistent student and I like that, okay? Good, good. Good to see that. Yeah, so channel efficiency, yes, if you want to call it efficiency, that's also very much true. Kisna Ram, okay? Good. Okay, then, okay, this is the question. Okay, so before that, I'm going to write few more formulas over here, okay, right? And that is waiting time in the queue equals to lambda upon mu into mu minus lambda, all right? And waiting time in the system equals to 1 upon mu minus lambda. All right, so these are formulas that you need to cram, guys, all right? Otherwise, no, it's not possible to solve the questions from here. Okay, hello? Okay, so I'll take that as a yes. So what I've done is, for example, see here, so this is length of Q, that is average number of customers in Q equal to this, okay? And if I divide this by lambda, if I divide this with lambda, okay, let me just write it, LQ equals to this thing and LS equals to this thing. So what is this relationship between this, okay? So you will realize that this is nothing but that is LQ upon lambda, okay? LQ is nothing but this, lambda square upon mu into mu minus lambda. If I divide this by lambda, I'm going to get this, right? Lambda upon mu into mu minus lambda. Yes, then this is also true, LS upon lambda. All right, so if I go back like this, So length of system is nothing but lambda upon mu minus lambda. So WS is nothing but LS upon lambda. That can be verified over here, all right? That is 1 upon mu minus lambda. Yes, hello. Is that good? So these are the relationships that we need to take care of. All right. Okay, then cram all of these formulas, guys, okay? And these two formulas and all of these formulas, all right? And yes, and Poisson's distribution obviously will be taken up in engineering mathematics, and also the exponential distribution, okay? And that's all. Is it good till now? Hello? Are you understanding this? I or an I? You just need to, cram all of these formulas, okay? Is it good? Is it good? Hello? Suryan Kumar says clear. Good to see that clear. Okay. Yeah. So what do you think it is? Clear? Okay, then just one I got. Ankit also said an I. What about others? Yes, Mohammed also said an I, okay, after so long, but it's fine, okay. So I'm going to take you through this question. So can you please try to do it? With rate of point this, okay, just remove this. With rate of this, average length of telephone call is 4 minutes and it is assumed to be exponentially distributed. Find average number of customers in the system, all right? So can you please do this? Can you please try this? Can you please try this question? Yeah, good to see that, Krishna Ram, Ankit, Srivastav. Good. So can you please try this? So what is lambda? Can someone tell me what is lambda? What is arrival rate? What is arrival rate? Can you please tell me? What is arrival rate? Lambda. Just type in, guys, all right? Just type in what is lambda. Okay, Sunil Kumar says that lambda equals 2. I'm not going to tell you. All right, so what is lambda? Come on. Just what is lambda? What is arrival rate? Ankit Srivastav says it's 0.4. Okay. Okay, fine. So we'll see that, Ankit, okay? Don't worry about that. Now 6. Oh, you're changing sides. So, okay, just do one thing. Obviously, lambda is nothing but, you're saying 6 per hour. So, that is also correct, Krishna Ram. But why do we need to convert it to hour, right? So, just it's given already 0.1 per minute. So, that's 0.1 per minute, all right? It's already given to us. If you want, you can convert it to hours, but it's fine, all right? Even if we stick with minute, that's also fine. So can you please tell me what is mu? What is mu? That is arrival rate. Okay, yeah, Ankit, yes. So if that's in per hour, yes, 6 is correct, all right, Ankit, yes, you're right. Don't take it very personally, okay. Mu equals 0.25 minutes per customer, yeah. Okay, so what is mu? Per minute we are talking about, okay? This is nothing but per minute. So can you please give me mu also in per minute? What should be the mu, the service rate? Okay, per minute I'm asking, okay? You need not do it in per hour. I'm just asking for per minute. What should that be? Mu equals to 0.25. Sunil Kumar says it should be 0.25. Others, guys, okay, I want your responses. Just give in your responses quickly. Okay, so Mohammed is already ready with answers, all right? Yes? Ankit, Vishwas says 6. Okay, so Ankit also says, okay, it's going to be 0.25. Others, just type in, guys. Just see that, you know, the unit has to be per minute, and we are given this average as 4 minutes. So can I write mu as 1 upon 4 minutes? Right? So in this way, you actually try to write service rate. That means 0.25 per minute. Right? If I take reciprocal of this, obviously I'm getting the unit of per minute, right? So it seems logical enough to accept this. Is that good? Yes. It has to be 0.25, guys, all right? Now everything's done. Now average number of customers in the system is what? A part. So what is average number of customers in the system? That is LS we are talking about. Okay. Yeah, so Mohammed is already ready with the answers. Okay, now, yeah, C and D also he has done. Okay, so LS is nothing but lambda upon mu minus lambda. So can you please calculate that? So this becomes how much? You just plug in these values, guys, all right? So can you please do this? Lambda upon mu minus lambda. Okay, so Ankit Srivastav says it has to be 0.67. Okay. Okay, rest people, just plug in the values, guys. Okay, lambda is 0.1, mu is 0.25. So this is nothing but 0.1 upon 0.25 minus 0.1. Please tell me how much is that. Okay. Just tell me how much is that. Come on, guys, come on. So it has to be 0.67. Is that good? Is this the answer? Is this correct answer? Can you think about it? Is this the correct answer? 0.67? Now this is the question, right? Is it correct? 0.67? Or shouldn't it be 1? Is the question. Shouldn't it be 1? Or it has to be, it can be 0.67. Okay, fine. So you have calculated this as 0.67. So shouldn't it be 1? Or should it be 0.67? All right. 2 live sessions. Shubham? Might be Shubham. Okay, 2 live sessions. Okay. Yeah, so what do you think it is? Is this correct? How many of you say that this is correct? 0.67. Type in I. And how many of you think that this is wrong? It should have been 1. Okay, type in, if you think it's 1, type in nai. If you think it's 0.67, type in I. Or you can also type, 0.67 or 1. It's up to you guys, all right? So are you getting the question? Is this correct or not? Okay, Mohammed says it is correct. Okay, 0.67. So, okay, so others, let me tell, others. Ankit Srivastav also says it is correct. Okay, fine. Others, just, now Mohammed says nai. Okay, now there's a change in the scenario. Okay, so Sulin says also correct. Okay, let me take one more option out there, okay, one more answer. Is it 1 or is it 0.67? Now, see, I have confused you, okay. Now, this is how GATE or ESE also confuse you. Mostly GATE confuses you, okay. Okay, correct, 0.67. Yes, 0.67 is correct, all right. This should not be 1. And why that? Because it's average. Average can be in fractions, all right. If it would have been, okay, total number of customers in the system, then obviously that cannot be 0.67, all right. So I'm going to just remove this and 0.67 is the correct answer, guys, okay? No, Muhammad, this is correct, all right, 0.67, because average can be in points as well. Is it good? Just typing I if you could understand this so that we can proceed further. Okay. Should we proceed further? Okay, good. Sunil Kumar says I, a very quick I like that. Okay, so correct 0.67, Krishna Ram. Okay, now option number B. So I'm going to just erase this and quickly move to option B. So what it says is average number of customers waiting to be served. So what is it? Waiting to be served. What do we need to find here? Come on. Just tell me, what do we need to find? Out of these parameters, whatever we have calculated over here, what do we need to find? Customers waiting to be served. What is the meaning of that? Okay, fine. So I'm going to just take you back here in this. So customers waiting to be served, if you can see this, all right. So how many customers here are waiting to be served in this? If you can see this, okay, how many customers are waiting to be served here? Chalo. Just tell me the answer of this, okay? At least 2-3 answers I expect, guys, all right? Even if they are incorrect, doesn't matter. Muhammad, okay, fine. So Muhammad says that, okay, fine. So he says that it's 3, all right? So let's discuss on that. So how many customers are waiting to be served? Yeah, now, yeah, Muhammad says it is 2, okay. Come on, guys, come on, I want more answers. Yeah, so we are talking about these people. There are 2 people out there, right? This one and this one. 2 people are waiting to be served. And I say that this is Q. Okay, Q means people who are waiting to be served, all right? Yes, exactly. So you are right, okay? Gaurav, Krishna, Kishore, you are right. Good. And 1 is getting serviced, all right? So, so if I talk about this thing, average number of customers waiting to be served is nothing but now length of queue, that is average number of customers in the queue or waiting in the queue, all right? Yes, good. Yeah, Mohammed, you're right. 1 is getting serviced, okay? Good, well done. So what we need to find is LQ, that is nothing but lambda square upon mu into mu minus lambda. Please give me the values, okay? Lambda is this one, mu is 0.25. Just give me the values. So 0.1 whole square upon mu is 0.25 and 0.25 minus 0.1, right? 0.25 minus 0.1. Was it good? Length of Q. Yes, Krishnaram. Good. Impressive again. Nice. You're doing good, all right? Yes. So, what is the value here? What is the value here? Yeah, Sunil Kumar, so what's the value of that? 0.01 upon whatever your answer is, okay? So just tell me the final answer over here. Whatever are you getting? Come on, let's do this. Yes. But good, impressive. You guys are doing great, all right? Okay, that is 0.267. Is that it? 0.267? Because Kishore says that it's 0.267. What is it? Come on, guys. Quickly calculate this. I don't have a calculator, otherwise I would have calculated. Being an engineer, we are habituated for using, yes, so 0.267, all right? So this is the average number of customers in the queue. Is that it? Yes? Yeah, so Mohammed is ready with his answers. So I'm going to accept this 0.267. Is that good? Hello? Okay, fine. So you just need to plug in the values in the formula and we are done. Alright, now C, average time a customer spends in the system. So what do you need to find out for C? Average time that a customer spends in the system. So what do you need to find? Yes, you're right. Okay, Kishore and Gaurav, you're right. Good. 0.267 is the correct answer. Now what about C? Okay, Mohammed, I know that you know the answers. Okay, let's have a discussion further with others. All right, those who are seeing it or watching it for the very first time, the queuing theory, I'm sure that they are going to take some time. So yes, Mohammed, you're right. Okay, so what is this thing? WQ. Yes, WQ is nothing but waiting time in the system. Average time a customer spends in the system, that is given by. So we are talking about C. So what is the formula for that? That is 1 upon mu minus lambda, right? Yes. So what is this? Just plug in the values. 1 upon average time a customer spends in the system is 1 upon mu minus lambda. So just plug in the values. Okay, 0.25 minus 0.1. All right, so is it coming out to be 6.67? Yeah, that is 6.67. What? Exactly. Kishore says that it has to be minutes. So yes, it has to be minutes, not hours, guys. Okay, sometimes we make some silly mistakes in this. Yeah, Prem Shila, a very good evening to you. How are you doing? I hope you are doing great. Is that it? Okay. Now, average waiting time of a customer before being served. So what do we need to find? D. For D, can you please tell me what do we need to find? Yes. Yeah, Ankit, good. That is waiting time in the system. So what do we need to find in D? Yes. Ankit, good. So what is D? Yes, Sunil Kumar, 6.67. That is the correct answer. Good. Well done. Okay. So what do you think about D? D. So what exactly do we need to find? D is nothing but average waiting time of a customer's in queue. Okay, before being serviced, he says. Okay, so that is nothing but Q. So we are going to say that that's nothing but lambda upon mu into mu minus lambda, right? Is it good? So this you can plug in the values. All right, but you can also find it using this LQ upon lambda, right? Length of Q you have already calculated, isn't it? The A part you had already calculated, so just divide that by lambda, so you will be getting the answer. Right? If you don't want to plug in all these values over here, LQ you have already found, right? In B part, LQ you have already found. So LQ upon lambda can also be done. Okay, so 2.67 minutes. 2.67 minutes. Is it good? Yes. Yeah. So Sunil Kumar says waiting of customer in queue, waiting time you should say. Okay, Sunil Kumar. Yeah, exactly. So waiting time, you have done that. Is it good? Hello. Is that good? Type in I if you want to move ahead. All right. Just type in I if you could understand this. Nah, if you could not understand it, there's nothing, nothing to be understood in this. It's just formula based. Whatever we have talked about is just about using formulas. Nothing more fancy. Okay? Yeah, so it's 2.67 minutes. All right. So what do you think is D? Sorry, E. What do you think is E? What do we need to find? Because firstly, you need to understand what you need to find, all right? This is nothing but 0.25 per minute. So what is E? Fraction of time during which booth is empty. Premshila, yes, CS is also available here, but this class is exclusively for mechanical engineering, all right? Okay, so Mohammed says the probability that system is idle. Okay, Mohammed, I'm going to come back to you, all right? So let's let others also talk about this, okay? Yeah, good. So what is this? Fraction of time during which booth is empty. What is that? AM. What is AM, Sri Hari? Can you please elaborate it? AM, if you're talking about AM, all right. What is the meaning of AM? Idle time of system. Fraction of time during which booth is empty. Yeah, Harshal, this is the first lecture, okay, but we have already talked about few formulas, but I suggest just stay here, all right? Just stay, yeah. So Sunil Kumar says that, okay, we are talking about when E, we are just talking about probability that system is idle, right? Empty means idle, there's no one in the system. Okay, I hope I have already answered you, Harshal, okay? You just be here. Just try to understand that. Probability that system is idle, because probability is also a fraction, right? So you can also relate some things like that, okay? Probability is also a fraction. So just a term fraction is going to maybe confuse you, okay? Yeah. So that is nothing but probability that system is idle is 1 minus lambda upon mu. Okay, so just tell me what is the value of this. Lambda upon mu is nothing but 0.1 upon 0.25. Is that it? So yeah, Srihari, it's fine, okay? I just could not understand that AM. You need not to be sorry about that. So what are you getting? Is it 0.6? Sunil Kumar says it's 0.6. Ankit also says it's 0.6. So I'm going to just accept that. It's 0.6. Is it good? Hello? Yeah. So Krishna Ram also says it's 0.6. So that confirms our answer. Now let's move to F. So what do you think F is? Probability of at least one customer in the booth. So what is S? Sorry, F. What is F? Yes, Mohammed, you're right. It's 0.6. Okay, you're already given your answers. That's really commendable. Okay? Chalo. Now, what is F? What is F? Can someone tell me what do we need to calculate in F? Probability of at least one customer in the booth. That means that at least one customer in the booth. What does that mean? Come on. P0 plus P1 that you say. No, Krishnaram, it's actually P1 plus P2 plus P3 and so on, okay, if you're talking in terms of that. Okay, so if at least one customer will be there, so the system is going to be busy, right? The system is going to be busy. So we are going to find probability of system being busy. Okay? And that is nothing but lambda upon mu. Yes, so that will come out to be 0.4. Is that it? Yes. Is it good? Hello, is it good? Yes, so 1 minus P0, that you can also do. Hello, is that good? I or an I? Yeah, it has to be 0.4, guys, all right? Now the next one, yeah, Mohammed is quick to say I like that. Good. Now the last one is G. Okay, G. That is nothing, a probability of more than 3 customers in the system. Can you please type in what do we need to find? Okay, good, Sunil Kumar. You are also very active, so that's also good, okay? So what do we need to find? Probability of more than 3 customers in the system. So what is that? Traffic intensity to the power 4. Is that it? So just tell me what it is asking for. Don't tell me the formula, right? Mohammed, what exactly do we need to find here? This is what I would like to know from you. Okay, Krishna? Yes, Mohammed, good that you have already calculated it, but yeah, let's take it easy, okay? Krishna Ram, just tell me, what do we need to find? At least, or it says that more than 3 customers in the system. So what do we need to find? 1 minus rho to the power 3. So, okay, Sunil Kumar says, okay, let's see if that comes up, all right? So what do we need to find is more than 3 customers in the system. So probability, there might be 4 customers, or there might be 5 customers, or there might be 6 customers, and so on, right? Isn't it? Now here, so I'm going to write just P4 plus, because OR symbolizes plus here, okay? Plus P6. And this might be written like this: 1 minus P0 plus P1 plus P2 plus P3, right? Isn't it? Because sum of all the probabilities is 1. Since P0 plus P1 plus P2 and so on is 1, right? If you add up the probabilities, they turn out to be 1. Okay, so can you please calculate all of them? So 1 minus P0 plus P1 plus P2 plus P3. So what is P0? We already know what is P0. Probability of no customers in the system, that is nothing but 1 minus lambda upon mu. Yes, P0 is 1 minus lambda upon mu. No customers in the system. Probability of 1 customer in the system is rho to the power 1 into P0. You just calculate this, right? Probability of 2 customers in the system is rho square into P0, right? Probability of 3 customers in the system is rho cube into P0. Alright, again where rho is lambda upon mu. This is rho, guys, okay? This is not P. I'm calling it rho. Alright? Yeah. So if you plug in these values over here, what are you getting? This is the expression that you need to calculate. So what are you getting? Yes. Traffic intensity lambda upon mu minus P1 plus P2. Okay, just tell me what are you getting through this. So let's see if you're getting your answers correct or not. And I've already explained P0, P1, P2, P3 can be found out like this. Okay, and in this case lambda equals to, mind you, lambda equals to 0.1, mu equals to 0.25. So what is the final answer? Come on, come on, come on. So what is the final answer? Sunil Kumar says 0.9616. Okay, let's see if he's right. So just type in your answers, guys, okay? Then we are going to end this. Okay. So what's the answer? Is there any difficulty in the streaming? Any internet issues out there? Because I don't see options. Okay, so Mohammed says that it's 0.02. Okay, good. Okay, so what do we have? Just plug in these values, okay, to this expression P0, P1, P2, P3. You're going to get the answer of come on, tell me. Mohammed says it's 0.02, Sunil Kumar says 0.96. Whom should I believe? Krishna Ram, how much are you getting? Come on, come on, come on. Give me the answer. Okay. Now it's going to bother me. Okay, Sunil Kumar, if you're wrong, just verify if you're getting 0.02 or what. Okay, so I think you can just plug in the values and get the answer here. But this concept is clear. It has to be more than 3 customers, means 4 or 5 or 6 or more, because this or out there, we are going to add this. All right, we are going to add that P4, P5 plus P6 and so on. That can be written like 1 minus P0 plus P1 plus P2 plus P3, because all of these probabilities equal to 1. Okay, so how much are you getting? 0.02. Okay guys, you just calculate that. Okay, just go back home and calculate this. So this is how it's done. All right, and okay, then we are done for today. Okay, Sunil Kumar, okay, no calculators, fine if you don't have calculator and all. Okay, so yeah, here also lambda upon mu, rho equals to, you can find this lambda upon mu, that is rho equals to 0.4, P0 also is 0.6, right? So kind of that. Is it good? So that is, Mohammed is saying 0.02, so I'm going to just write. Okay, you can just calculate this, guys, all right? Don't worry about anything else. Okay, now, is it good? Just calculate that. Okay, so then 0.02, I'm going to write 0.02 is the probability. Okay, so that's what it is. No problem. Even if this is wrong, you need to get the concept right. Okay, I have given you the concept. It's good. It's sufficient. All right, guys. Now we have a Vision 2021. Batch 2 has already started. Batch 1, we have already finished 2 chapters. Not chapters, actually 2 subjects. Firstly, we started with industrial engineering. Now heat and mass transfer is getting finished. All right. Okay, then yes, if you think that we can provide you the value, you can join us. All right. And yes, we also have some discounts here. All right, then you can check these discounts. This is the number to be called and this is the email to be dropped. All right, again, thank you very much, Mohammed, Krishna, Sunil Kumar, Kishore, Ankit Srivastav, so that you came here and you have had a session. All right, you at least tried. And I'm going to see you tomorrow again, same time. All right, and be blessed by the divine. Keep on smiling and keep on dreaming, keep on working. All right, and then yes, it can be done. Okay, okay, fine. So Krishna Ram says that it's actually 0.334. Don't bother about that. Okay, so just go back and because 2 people said it's 0.02, so I've written 0.02 over that. Over there, just a calculation, guys. Okay. So just share this video, like this video if I added value to your lives, all right? Because it is going to help me and okay, and others who are going to watch this. Okay, yes. Okay, Sunil Kumar, 0.02. I'm going to take that. I believe in you. It's fine. All right. So again, same time tomorrow. I'm going to catch up with you guys. Keep on smiling, because once you become happy, your performance also increases, your efficiency also increases. With that thought, a very good night to you.